going. We will be presenting the enzymatic action inactivation of penicillin G by the enzyme beta-lactamase TEM1. This is the active site without penicillin G. This is the active site of beta-lactamase. And the main amino acids I want you to pay attention to are serine 70, glutamate 166, and also this constituent water. This is an endogenous water molecule that stays inside the amino acid. And these are just showing the external structures where these amino acids are bound to. Your alpha helix, your beta pleated sheet, and your gamma loop. So here we have the penicillin, and it's in the active site right here. It's stabilized by hydrogen bonds to the nitrogens on alanine 237, and that's the only part of the reaction that takes place, is stabilizing this oxygen. And the serine 70's nitrogen also has hydrogen bonds with this to stabilize that.
Like you, so you shouldn't complain.
Half another.
Oh, I'm glad.
And the water molecule is also stabilized. It's an important part of the reaction because you need to deprotonate this serine in order for it to be able to act as a nucleophile on this carbonyl. And this glutamate's too far away to abstract that proton. And it also seems weird because glutamate's low pH. It loses its proton readily. But in this case, in this study, it showed that this is the actual base of the reaction. It abstracts this hydrogen. At the same time, the water abstracts the proton from serine. The rest of the hydrogen bonds stay the same, keeping penicillin stuck in the same spot. So you come down here, and you have a deprotonated serine, a water molecule with the hydrogen from the serine, and a protonated glutamate. Now this reaction is able to act as a nucleophile now. So you go in there and you kick out a pair of those electrons. This comes down because you have your tetrahedral intermediate up there, and it kicks out this bond, but that's an extremely unstable nitrogen negative. So one of those protons, or those pair of electrons, grabs that proton. This hydrogen bond abstracts that proton again. So the next structure we have is the beta-lactam ring is now broken open. Your water's back to where it was. Your glutamate's back to where it was. Now all that we have to do is basically hydrolyze the ester bond that's between the serine and the beta-lactam ring. And what happens is an exogenous water molecule comes in, is deprotonated by this nitrogen. So it abstracts that proton, leading to a hydroxide molecule. This is a good nucleophile again. That oxygen attacks there, boots that off. So this one is now an O-, and this abstracts the proton that this nitrogen originally had, leaving you with the exogenous water molecules, hydrogen peeled off by serine, and then the rest of the enzymes the exact same, and you have your inactive penicillin.
Is that it?
That should be it.
Yeah, good job, Colin. Yeah. Okay.
And we'll act it out for you, so it'll be a little better.
Okay.